Can you hear me, Shana? Hello. Can you hear me, Shana?
Oh, hi.
Hi, Shana.
Hi.
Yeah.
I have another class after this. I have a Talmud class. I have only until 8 o'clock.
Okay. So how many minutes you do have?
15 minutes.
15 minutes. Okay. So can we have this 15 minutes class?
Yeah, we can have.
Okay. 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 So you are learning Tamil.
Yeah.
That's nice. Subdivision A. A cylinder has a height of 10 and radius of 3. Determine the total surface area including the two ends of the cylinder and also determine the volume of the cylinder. I hope you have learned a chapter called mensuration in your early classes. Yes.
Um, yeah.
Okay, I just wanted to show a small video on the cylinder. Okay, I think you'll be able
Oh,
to
okay.
understand. Like imagine a situation like um if I cut the cylinder over here and here, if I open the cylinder like cross sectionally, I would be able to form a rectangle. Can you follow that?
Yeah.
Yes.
Yeah.
And also like if I fold the rectangle, like if I try to fold this end and this end together, I would be able to make a cylinder, right?
Yeah.
Okay, okay, fine. So now for calculating the total surface area of the cylinder, area of the cylinder, you should add the surface area of the top, surface area of the bottom, and this middle portion.
Yeah.
So you know the tops looks like a sphere. I mean a circle, not a sphere, a circle. The top and
Yeah.
bottom both looks like a circle. So if you substitute the surface area of this formula, you will be able to find the surface area of the top and bottom. Okay. So you know the formula for the area of the circle, which is nothing but pi r square, right? So for the top, it is pi r square, and for the bottom also, it's going to be the same pi r square. If you add them, you're going to have the result as 2 pi r square. Yes, and you can substitute the value of radius over there, and radius is 3 centimeter, right? So it's going to be 2 pi into 3 square. Can you follow this, Shana? So it's 2 into
Yeah.
9, which will give you 18 pi. For calculating the lateral surface area, I just said this. Like assume you are just making a vertical cut through the cylinder and unroll the lateral surface, you'll be able to obtain a rectangle, right? And we know the height
Yeah.
of the rectangle is 10 centimeter. So we can say this is 10, right? And what about this one? This is nothing but if you fold it, you would be able to form a circle, isn't it? By using the top and the bottom. Like if you fold them vertically, you would be able to see a circular shape. So I can say this length is equal to the circumference of the circle. Can we say that? Width of the rectangle and circumference of the circle are same. Yes, Shana?
Yeah.
So you know the formula for the circumference of the circle, right? It is 2 pi r. This is the formula for circumference of the circle. So which is nothing but width of the rectangle. So it's 2 pi r. You know the value of radius. It's nothing but 3. So it's 6 pi. Is it clear?
Yeah, that's
So the
clear.
width of the rectangle is 6 pi. For calculating the area of the rectangle, you know the formula. It's length into breadth. So it's going to be 10 times of 6 pi, which will give you 60 pi. So that is your surface area of the mid portion. So you just have to add this 18 pi and 60 pi for calculating the total surface area of the cylinder, which is nothing but 78 pi. Is it clear, Shana?
Yeah.
For finding the volume of the cylinder, you should be aware of the formula, which is nothing but pi into r into square into h. So you just have to substitute the values of radius and height, which is already given in the question. So it's pi times 3 square into 10. So that will give you pi into 9 into 10, which is nothing but 90 pi. I hope you are able to follow this.
Yeah.
We go to the next subdivision. A cone, a cylinder, a sphere all have radius r. A cone, a cylinder, a sphere. The height of the cylinder is capital H and height of the cone is small h. The cylinder and the sphere have the same volume, okay, which means like the pi r square h and what is the formula for the volume of the sphere? It's 4 by 3 pi r cube. Simple. 4 by 3 pi r cube. So they're saying that this 4 by 3 pi r cube is equal to the volume of the cylinder, which means pi r square h is equal to 4 by 3 pi r cube. Huh? So you can cut pi and pi, r square and r cube, like this becomes like 4 by 3 r, and you will have h here. So from this you can relate h is equal to 4 by 3 times r and r is equal to 3h by 4. So you can
Yeah.
derive these two relations from the statement. Can you follow, Shana?
Yeah.
The cone and the cylinder have the same total surface area. Prove that h and small h and capital H cannot both be integers. Okay, this is kind of easy only. So this relation I just showed, right? H is equal to 4 pi 3 r. Very simple. And also in the second statement, they said like the total surface area of the cone and the cylinder are equal. So you should be aware of the formula. Okay. This is the surface area of the cone. It's 2 pi r square plus 2 pi r h. And for the surface area of the cylinder, it's pi r square plus pi r into s. So we have to simplify this relation. Okay. So you can take 2 pi r as common from the left side, and you will be left with r plus capital H. And from the right side, you can take pi r and you will be having like r plus s. So pi r will cancel out each other. We'll be having 2 times of r plus h is equal to r plus s. So it will be 2r plus 2h is equal to r plus s. So it's 2r minus r plus 2h is equal to s. So if you subtract r from 2r, you're going to have r plus 2h is equal to s. Can you follow this, Shana?
Yeah.
So we need to prove that the small h and capital H cannot be integer. So they're saying that you need to get some information about this capital H and small h. And also we need to eliminate this s. This s is nothing but slanting height. Okay. Like imagine you have a cone like this. You can create a rectangle, a right angle here, a right angle triangle. So we knew this looks like a circle, so you can say this is the radius of this circle, and this is slant height of the cone, and this is h. So if you apply Pythagorean theorem, you can say s is equal to square root of r square plus h square. Can you follow this, Shana?
Yeah.
And from the above relation, we derive the value for s, which is nothing but r plus 2h. So you're substituting that instead of s here. And you have square root in the right side. And also from the first statement, we derive the value of radius as 3 by 4 times of h, right? So that substitution you are over here and here, substituting. So you just have to simplify this by taking LCM. This one you need to square and take LCM. Just square both the sides for eliminating the square root. Very simple calculation. So you'll be having like 121 upon 6 h square. But here you do have 9 upon 16 h square. Just take it to the other side. It becomes like 112 upon 16 h square is equal to h square. So if you simplify this 112 and 16, you're going to have like 7. So it's 7 capital H square is equal to small h square. So if you take h square root for both, you're going to have like small h is equal to square root of 7 into h. Yes, from this relation, we can say h is equal to square root of 7 into h. So this square root number is nothing but a irrational number. Definitely you won't be able to find any integer value out of it. You can't get any integer value, right? So from this we can prove h and capital H cannot both be integer since root 7 is irrational. Can you follow the Shana?
Yeah.
That's all about this problem. I think we do have only 2 subdivision in this problem. Okay, that's it. That's it, Shana. I hope you understood the question number 3 and 4. All right. Okay, Shana. Then shall we stop here?
Yeah.
Okay. Okay, in the next class we'll discuss the 2007, right? I mean 2006 Galois Contest. Okay. It's done.
Yeah.
Have a happy weekend. Bye bye.
Okay, bye. Thank you.
Thank you.